So, good morning, calculus people here in the real world. It is about 10 a.m. I was going to call one of you to make sure I'm looking at the right sheet, but we were undecided, my director and I, as to whether people would be awake at 10 a.m. So, I'm just going to hope I have the right sheet. The sheet I'm looking at starts with a problem with 1.4 to the x power. If those aren't the problems you're looking for, I'll have to try this again, but at least you have a video for some questions from another paper some other day, I guess. But whatever paper starts with 1.4 to the x, this is where I'm looking based on the requests that I received. So the first request I got was, they're on the board, so we'll just leave this up here. But before I do this one, I'm going to take a little small walk slowly with my director following me to the basic knowledge section. So a more basic version of this, just to make sure you have the foundation to do it, is if you're doing the derivative of E problems, the key thing is to copy the whole E thing to a power, but then that's going to have to multiply the derivative of the power. And the derivative of 5x is a 5. More likely, for neatness purposes, we'd rather write the 5 before the messy stuff, but that's not crucial. But the idea of E derivatives is crucial to do number 10. So if you don't understand that, you're not going to understand what I'm about to do. But hopefully you did understand that, and then I'll take a walk back over here to the left. This one's based on your least favorite rule, the quotient rule. So the quotient rule, we need to copy the bottom times the derivative of the top. On the derivative of the top, this vanishes. The derivative of this means to copy it as it was. To do the derivative of the power, which would be a -1. And all that -1 is going to do is change this negative thing to give us a positive version, and we're halfway through it. Minus, I'm going to copy the top exactly as it is, times the derivative of the bottom. This is the greatest derivative ever because it is just itself. We copy the e's always just themselves, but the derivative of the power is just a 1, so that's outstanding. This is all going to end up on the top. I'll worry about the bottom squared in a second. If we multiply these, we would look to add the powers. Same bases, add powers, could be a 0, and I'll clean that up in a minute. Minus, if I distribute these while I'm also operating on the minus, 1 times e to the x is e to the x. The minus here makes an e to the x. If I multiply these while considering this, minus and minus is a plus. This is another e to the 0 that I'm going to clean up in a second. I didn't budget myself enough space, so I'm going to erase the original problem and then work back up to the top. Anything to the zeros are 1s. Anything, including e. So 1 plus 1 is 2. This is staying as it is. And then we need for our answer to have the original bottom, but squared. You could write it like that, but that's a little bit weird looking to me. The parentheses make that less simple looking than it needs to be. When you have powers and powers, you multiply the powers. So I feel like a better thing there would be a 2x. This one is based on the same basic idea, E derivatives, but this is product rule instead. When I go to get an answer, the answer is going to still be over 3. Anytime there's a number like that, that's harmless. Just ignore it. It's going to be in the answer just to make my life a little simpler. I'm going to erase that from existence because I have myself covered because my answer is going to live here and it's going to be over 3. And we're doing the product rule. So I copy the first times the derivative of the parentheses, second group. Derivative of sine is cosine. Derivative of cosine is negative sine. Since there already was a negative, that's plus. Then I go plus. I need to copy the second one as is. And I need to do the derivative of the first, which is again the greatest derivative in history. That's e to the x's. And then I try to put things together. This e cosine is useless because there's a negative version of it over here, and those are going to go away. The E sign is useful because there's another E sign over here. So grand total, we have 2 E's and signs, and the 3's been waiting all along. Up to 17. 17 is based on the idea of inverses. Inverses is the day where we switch the X's and Y's. So when I wrote you this problem, I made a basic problem in the real world, and then I asked you a question about the inverse world, where X and Y has been switched. In inverse world, where X and Y has been switched, we're looking at the 0.71. In the real world, therefore, we'd be thinking about the 0.17. For the 0.17, we'll need that in a second. So what you were asked to do in this problem is to do the derivative, which is 12x minus 7, with the 8 disappearing. You're asked to then plug in, sort of, I didn't say words plug in, but you're being asked to plug in the x, which is the 1, because we're in the real world, not the inverse world where they got reversed. So we plug 1 into this, and we'd be looking at a 5. Then there's a trivia question going on, where in inverse world, what happens when you switch the ordered pairs, like 1, 7, 7, 1, it just flips the derivative answer you got that's 1/5 then. You might remember in the homework, they first started you doing this a long way, where they'd make you figure out the inverse, do a derivative over here, there was like a second big long column, and the answers always ended up just being flipped. And then we cut a corner and said, don't do that the long way, just live in the real world, having switched X and Y back from inverse world, and just flip. For 23, the concept is we're trying to solve equations. An equation is like a scale. Whatever you do to one side, you do to the other, like those old scales that are good for weighing things, like ducks. Special reference there from my director to understand. She enjoys that reference. So what we're looking to do here is do opposites, solve for x. What's the opposite of e's is ln's. So I would do an ln here. That makes me do an ln there. ln's kill e's, and that leaves me 2x. We would be just now showing up for chemistry if you were here in the real world with us. Over here, I could leave this as the ln of 1/12, but I cleaned it up. On the answer I did, instead of writing ln of 1/12, I wrote negative ln of 12, because that seems simpler to me. Fractions are not desirable usually in math, and we had a logarithm property we learned that if you ever want to flip a number, you can feel free to do so. It just takes a negative to pay for that, and that's what I did, because it looks cleaner to me. This looks better to me than this, because I'm about to divide. So if I want to get to x alone, I'm going to look to divide by 2, and that looks like a better answer to me than this would. This would be technically correct, but that just, it looks better. Okay, so I went that direction. If you did this on a test or something, life would go on. That's not the main theme of that question. To do 24, I'm going to take a brief walk over here to basic area again. So here's one of the other properties of logarithms in basic form. Here's the one I just did. I just did ln of something like 1/5. Instead, I can trade that for ln 5 to throw a negative in there. Those two things are tradable. That was a thing we had learned. What we learned about powers that same day is that powers are able to, instead of being powers, just be numbers in the front. So if there's a 10 in the front, you could return it upstairs. Or if there's a 10 upstairs, you could return it to the front. It works in both directions. It's just a question of which way you want to go. So back to 24, you just need to apply that in either direction for consistency's sake. If you want to bring the 2 down, I think this is the easier approach. 2 comes down to make a 4, and then you'd have like terms. You'd have 5 log x minus 4 log x. Since they both have log x, they're like. So 5 of them minus 4 of them is one of those, but realistically, the 1 could be invisible just like we usually like it, and that to me is the shortest route. Alternative path is, instead of bringing the powers down, put the numbers in front, back. So the 5 could go up, the 2 could go up, 2 times 2 is 4. And then we have another thing that we've learned about logarithms. If you have two logarithms that are subtracting, you can consolidate it to be one logarithm, but divide. X to the 5th is first, so top. X to the 4th is second, so bottom. When you divide with powers, you subtract them. So x would have a 1, which could be invisible, and that's a duplication of the same answer I did a minute ago. It's a different road. I think a little longer road probably, but all roads should lead to ln x. 32 was the day it was called logarithmic differentiation. So when we did the logarithmic differentiation answers, the original thing was always still present in the answer. So when I make an answer, I need the original thing in it, so that's coming. On the sheet, I don't think I, on my answer key, ever have recopied the full answer. I think I take the problem and kind of like build the answer around it. So I don't have space, I don't think, to do that right now, but the original thing is just going to be in the answer. 6th root is a 1/6 power. And we want to do the same thing with the 1/6 power we just talked about with the powers on this. The powers can go to the front. So 1/6 can go to the front. Then there's going to need to be some new creation of things based on these. Every group of parentheses gets ownership of its own fraction. We're doing log differentiation, so let me slide left here for a brief timeout to basic zone. When we do logarithm derivatives, they're always fractions. The original thing I give you goes to the bottom. Its derivative goes to the top, with possible ability to clean up. So here we could cancel the 6's to get 1's. If you want a handy shortcut, I usually give people during the review, in the long run, whatever the power was on x ends up the top, and always x ends up the bottom. So if I decide to do a 5 there, this would just be 5 over x. To prove that to you by doing a longer version, I could go 6x5, its derivative, 30x4. This will always be 1 less than that, so it'll cancel back down to an x. And 30 dividing 6 gets back to the 5 that I said. It just happens. So if this is a 57, and this is a 96, doesn't really do anything other than make that a 57. Just handy trick. Back to the left. So 3x plus 7 needs to take ownership of its bottom, of its fraction. X squared plus 5x plus 6 takes ownership of the bottom of its fraction. In logarithm world, anything that multiplies is an add. Anything that is dividing was a subtract. And then on top, we need to do the derivatives. The derivative of this is 3. Be on the lookout for a triple play of reducing, but you can't do it unless you get triple action here. 3 could try to cancel 3, but 7 can't play, so you don't do that. If the 7 were a 9, then you could divide them all by 3. That's not the case. Top of this, I go 2x plus 5. Be on the lookout for factoring availability. If this had been 2x plus 6, I could have pulled out a GCF2 and had x plus 3. The bottom would have factored to have a matching x plus 3. I could have gotten a nice little cancel out of that with a 6 here, or a 4 there would have worked too. But that one's done. That's as far as I can go with that one. To do 39, I'm going to take a little step toward easy zone, where we learned one day if we had logarithms of different bases, we could make a fraction style thing out of that with ln of this copy on top of ln of the base copy. And this is just a number like the 3 from way back at the beginning. I had a 3 that was on the bottom of a fraction that I ignored and it made it be in the answer. That's a number like the 3 was. It has an ln in it, but it's still just a number. So I'm going to do that on this one. I'm going to go ln x on ln3. I'm going to do ln x on ln5. And then I'm going to create an answer world. We don't need the board anymore, do we, Director? Probably, or you like to do the scan through?
It's fine. It's gonna work.
I'm just going to create a little space back this way because we've already captured that. If I step this way to make some kind of an answer zone, I can safely at this point discard the ln3 and discard the ln5. Those are multiplying, so I just threw a multiply symbol right there. But those are just numbers. I'm going to scoot them out of the way because I don't feel like looking at them right now. Instead of looking at this and having to do the product rule, I think I'd rather think of that. It's going to be easier, and now we're going to do the chain rule. For the chain rule, we're going to work from the outside in, which means the 2 would be out there first. So to do the derivative of stuff to the second, it's 2. And then decrease the power by 1, there'd be an invisible 1. But we also have to do the derivative of the inner piece. To do the derivative of the inner piece is like the easier question that I just morphed into the 57 and all that over here, and we're doing one of those. It's just a fraction, x on the bottom, its derivative on the top, or shortcut world, the power was a 1, so just do 1 on top of an x. This just needs to go transform now into answer world. Okay, so 2 is coming, ln x is coming. The 1 over x, I'm just going to put an x on the bottom. That's its most natural one. 42 is based on, do I have one for this? No, I don't think so. I think we're just good on this. If we have numbers to powers and you want to do the derivative, you're always going to just copy down the original thing. It's just there. That's part of the answer. So within the problem space, I'm going to create an answer space that includes the problem itself. We need to do the derivative of the power, which is going to take a chain rule. I'm just focused on this now, working from the outside in. The derivative of tan is secant squared, but I have not yet touched the 5x. My attention only fell on tan. Derivative of tan is secant squared. I need to do the derivative of the 5x that I ignored for a second. That's a 5. And then there's also an ln of 4 because your card says so. If there's a 4 to the power, it's ln 4. 2 minutes? Okay, so 2 minutes and we're out of card space. So for this fits no pattern, so I'm going to pick a u is ln of x. du is a fraction derivative, which is 1 over x. So for this problem, I'm ignoring the 5, scoot it out of the way. This ln x I'm calling u. The 1 over x thing, that's du. So I can do that exchange. Antiderivative is half u squared with a fifth still there. That becomes 1/10 u squared. And then for the answer, I need to re-replace 1/10 ln of x back home squared plus our good friend the c. Sorry, I went a little fast there, but if it was too fast, that's the beauty of the video. Rewind. If I could have gone a little faster throughout, let me know. It shortens down the experience for me, but if that was a nice pace, let me know. I'm very open to feedback. Too fast, too slow, too little, too much, whatever. So, hope all is well in your world. Let me know if you need more.